Here I've got a multiband compressor and a dynamic equalizer. I've chosen these pretty much at random, actually. They just happen to be ones that I have on my system. I've got the Oxford Dynamic EQ, which is a really nice dynamic EQ, and I'll come back to that because it's quite special in one particular way. And the Ozone multiband, which I just happen to use because I have it. And what we've got here is I've got two of them running. They're receiving a pink noise signal from a signal generator. They're both listening to the same bus, and they've both got trim plugins on, and one of them's got inverted polarity, so it's cancelling. So if I flip this, there's the noise. Now, at the moment, we're hearing almost nothing. There's a tiny little bit of signal coming through. But what you'll notice is that if I come in here, and this is kind of the reason why I chose the Ozone, we've got these crossover regions between the different bands, and stuff can happen in there. Now, we've got a lot of control over that in here, because if we come in here, what we have is we have crossover types. At the moment, we're dealing with crossover hybrid, and if we look at the latency that's being introduced, the multiband compression is introducing 384 samples, whereas of latency, whereas the dynamic EQ only 50. But if we change this to analog, what we'll get is much reduced latency, but that will be at the expense of the phase linearity of the crossovers, and we'll hear a load of stuff that wouldn't otherwise be there. And there it is. If we go to digital, we'll see we have 638. If we go to analog, 0. If we go to hybrid, 384. So there we go. We've got playing off this compromise between the phase behaviour of the crossover filters and the latency that they induce. We don't get that with a dynamic EQ.